All right, so here we are now into chapter 18, amines and amides, and we mentioned them a little bit in the last chapter, and I told you to hold off, that you'd be learning more about them now, and here we are, ready to do just that. In this first lecture, we're going to focus on the amines, and we'll give a general overview of them. They're not terribly pleasant smelling, but they are some important organic compounds, and not only for their organic chemistry, but also their biological chemistry that we'll learn about here. So as their name hopefully suggests, amines are derivatives of ammonia, although we have gone from the two M's for ammonia down to one M for amines. In the IUPAC nomenclature, we have the E at the end of the corresponding alkane name replaced with amine. Makes life really easy. If you're using IUPAC names, you should have no trouble picking out amines. So if we look down at the bottom, we see our simplest case there, the first one, ethane, which we could have even below it, methane is the very simplest. And then the E in either ethane or methane becomes ethanamine or methanamine, as the case may be. Once we get to 3 or more carbon atoms, we do have to number in order to show where the NH2 group or NR2 group, depending on if there's any additional nitrogen carbon bonds, as there can be and as we'll talk about in the upcoming slides. So we see 1 propanamine, 2 propanamine, just like we had 1 propanol and 2 propanol. So it's not a terribly different scheme. It's just once we get to those 3 carbons, we do have the possibility of having the substituent on either a terminal or an interior carbon atom. So let's go back to our guide. We didn't have too much trouble, I hope, naming the lipids in the previous chapter, but now let's go ahead and use our guide as a help to figure out this IUPAC naming of amines. So first, we want the longest carbon chain that has the nitrogen atom of the amine group contained within it. We'll replace the E of its regular alkane name with amine. Second, we'll number the carbon chain to show the position of the amine group and any other substituents that might be relevant. And then finally, any alkyl group attached to the nitrogen atom is indicated by the prefix N, and then a hyphen, and then the alkyl substituent's name, which is placed in front of the amine name. So that's how we know that it's a nitrogen bonded methyl group, for instance, as opposed to a regular methyl group on a different part of the chain. All right, so let's practice with this example. Here we have a nitrogen with 3 bonds. That's a classic amine, or ammonia if all 3 bonds are hydrogen, but in this case we have 2 bonds to carbons and 1 bond to hydrogen off of that nitrogen. So this is an amine. There's a 4 carbon group, there's a 1 carbon group, and then there's the hydrogen. So obviously, in order to name this thing correctly, we're going to look at the longest carbon chain, which would be the butane. We'll take that E ending off of the alkane name and replace it with amine. So this is a butanamine, definitely not a methanamine, although we do have that methyl group that we will have to deal with in a moment. Before we deal with that methyl group, though, notice that it's a 4 carbon chain, right? So we said once we hit 3 carbons or more, we do have to indicate the position to which that nitrogen is bound. So in this case, because we number starting at the end nearest the amine that still contains it, this is a 1 butanamine. So we're on that first carbon of the butane chain, and therefore we're a 1 butanamine in this case. Now finally we're ready to handle that methyl group coming off the other side of the nitrogen in our depiction there. So because it is connected to the nitrogen of the amine rather than being, say, off of carbon 3 of the butane chain, we do have to name it with that capital N prefix, technically italicized, although I don't expect you to write in italics. If you do type it, that would be nice. So capital N dash, and then in this case it's a methyl group. So officially, if we put everything together now, and those alkyl groups attached are listed alphabetically. In this case, we just have the methyl group, the other position's a hydrogen, but if we had, say, an ethyl group on the other position, then we'd name the ethyl group, then the methyl, but we'll handle that when it comes. So this one, the IUPAC name for this particular structure is N-methyl-1-butanamine. Hopefully that's fairly logical and you were able to follow that, and we'll take a look now at some naming the common amines instead of the IUPAC names. We've had a number of types of functional groups that have had common names that are as common or more common than IUPAC names, and unfortunately, again, amines will have very often their common name used instead of their official IUPAC name. So looking at these different names, we see that they're not quite the IUPAC. So ethylamine is what we would have called by IUPAC rules ethanamine, right? So similar but different. Then we have a dimethylamine, which we would have named by IUPAC rules as methyl N-methyl methanamine. And then we have our ethyl dimethylamine, which we would have named, of course, N N dimethyl ethanamine. So not too different, but different enough to cause us some trouble if you don't realize that these common names are going to be out there, and you may certainly come across them from time to time. All right, so why don't we pause here for a learning check. In this particular learning check, you're asked to give the common and IUPAC names and then classify each as either primary, secondary, or tertiary, right? The nitrogen can make 3 bonds. If it's just 1 bond to a carbon group, that's a primary amine. If it's 2 bonds from the nitrogen to 2 different carbon groups, then that's going to be a secondary amine. And finally, if all 3 bonds from the nitrogen are to carbon groups, then that's a tertiary amine. So please go ahead, pause the video here while you complete those tasks, and start us back up when you're ready to check your work. Good luck. All right, hopefully you didn't have too much trouble with that. Let's go through them stepwise. First, we'll look at letter A there. So step number 1 is to name the longest carbon chain bonded to the nitrogen as an alkanamine by replacing that E of the alkane name with amine. So that was a propanamine. Step 2, we're going to number the carbon chain just to show this position. It is a 3-carbon group, so we do have to indicate that this is a 1-propanamine by IUPAC, or if you're doing the common names, it's just propylamine, right, giving the carbon group's name abbreviation in front of the word amine for the common. Either way you do it, it is a primary amine. That nitrogen is bonded to only 1 carbon atom. The other 2 bonds are to hydrogens. So there we have it, whether we call it propylamine by the common name or a 1-propanamine by the IUPAC nomenclature scheme, it is definitely a primary amine. If we look at B here, now B was a little more complex. So step 1, still the same. We look for the longest carbon chain with the bond to the nitrogen and take its alkane name and replace it with amine. So it's an ethane would be the longest, and then 2 methyl groups. And so therefore it's an ethanamine. Step 2, we number the carbon chain. Of course, because it's just 2 carbons, we don't have to worry about saying which carbon is bonded to the nitrogen because they're equivalent. We'd have to be at 3 carbons or more to have to worry about that. Okay, and then finally for that second structure B, we have step 3 here because we have to consider how we're going to name this thing. If we use the common nomenclature scheme, we just name each of those groups, how we would name them, put them in alphabetical order, and then end with amine. So this would be ethyl dimethylamine. Notice the di doesn't get priority in alphabetical order. It's just to indicate that there are 2 methyl groups. It's the ethyl group, which is alphabetically first, that comes first in the common name. For the IUPAC name, we already said it's an ethanamine. It is also an N, N dash dimethyl ethanamine. So that's how we indicate that both of those methyl groups are bound to that same nitrogen. Either way we do it, because the nitrogen is bonded to 3 different carbon groups, it is a tertiary amine. Hopefully that went well. If that's not the case, if you struggled there, let's do the next learning check and then we'll see if you continue to have difficulty. Okay, so as promised, here's another learning check. This time you're asked to draw the condensed structural formula, or as you know, the skeletal structure is what I prefer, but whichever you can, or if you can do both, go for it. For each of the following, so we have 2 structures again. That this time we give you the name and you're going to come up with the structure, the exact opposite of last learning check. So we have A2-pentanamine and B N-methyl-1-butanamine. Please go ahead, draw those structures, and stop the video here while you do that, and start us back up when you're ready to check your work. Good luck. All right, so there we have it. So two pentanamines. So we have the 5 carbon pentane chain, and then we have on carbon 2, could either be the second in from the left or the second in from the right. They're equivalent, and we show the NH2. If you did the skeletal structure, just remember you would show the H2 after the N. We don't just assume there to be hydrogens there as we do with carbon atoms. So just be careful to show that if you did the skeletal structure. But there's the condensed structural formula. For B, we have the butanamine, so 4 carbons. It's a 1-butanamine, so we're off that last carbon there. And then we also have a methyl group coming off that nitrogen. And then finally, the last position would be a hydrogen. So there we have a condensed structural formula for that. Now that's notable because that is actually a secondary amine, and I don't think we took the time to point out any other secondary amines. In the previous learning check, we had a primary and a tertiary amine. Here we have in A another primary amine, and then in B a secondary amine. So you've seen the 3 major types of amines, and we'll also talk about quaternary ammonium salts in this chapter. Now this came up in the last chapter when we were talking about some of those phospholipids because they involved amino alcohols. So what do we do? How do we name compounds with 2 functional groups? Well, we have to identify which group is the priority, which group has the priority, I should say, which group is more important, so to speak, and therefore which other group gets named as a substituent. So according to the IUPAC rules, they've thought of everything, right? An oxygen-containing group will have priority over a nitrogen-containing group like an amine or an amide that we'll talk about in this chapter. So as a result, the NH2 group is named as the substituent amino. So we dealt with some amino alcohols last chapter. We have here a few examples of, at least in the first case, another amino alcohol, 2-amino-1-propanol. Then we have an amino ketone in the middle there, 4-amino-2-pentanone, and then finally an amino benzoic acid, or an amino carboxylic acid rather, 3-amino-butanoic acid. So there we have it. You see those oxygen-containing groups went out over the amino group. And here we have in table 18.1 a priority of functional groups in the IUPAC nomenclature scheme. So the highest priority is the most highly oxidized, the carboxylic acid groups. And of course, the name of that compound ends in oic acid. Next in priority is the esters. Those had 2 bonds to oxygen, a double bond in the carbonyl, and then a single bond to another oxygen. So similar to the carboxylic acid in terms of the number of oxygens, but just lower in priority. It's an anoate is the way it ends. And amide, which I mentioned is similar to an amine in that it has a nitrogen group, still retains high priority here because it also has the carbonyl. So here it's 3rd in priority of the groups that we've talked about, and the name of the compound ends in amide. If it were named as a substituent because it were bonded to something that also contained an ester or carboxylic acid, for instance, then we'd have amido. So aldehydes are slightly higher priority than ketones if you have to make the difference. And then we see an aldehyde gets named as a formal substituent, ketone gets named as an oxo substituent. Alcohol is higher in priority than the amines, and that's the case we just ran into, but it is a fairly low priority group compared with all the other functional groups we've learned. So it's often named as a hydroxy group. And an amine is one of the lower priorities. Basically, it only outranks an alkane, and so the amine ends in amine, or when it's a substituent, as it would be with pretty much any other functional group, it's amino. Then finally, an alkane, as we know, ends in ane if it's the compound, but alkyl group is how it's named as a substituent, so methyl group, ethyl group, so on and so forth. Finally, if you have a halide, that's named as a halo group. There we have it, our priority of functional groups in IUPAC nomenclature. Now let's talk a little bit about aromatic amines. So the amine of benzene is called aniline. And actually, if you're in the Triple Cities area, you probably I've heard about. GAF was a big company here in its time, and that was General Aniline and Film. So aniline was important in the filmmaking process, and therefore it has its legacy here in the Triple Cities area of the southern tier of New York. But it still retains quite an important place in chemistry because aniline is the basis of many other things. And so if we have just that benzene group with a single NH2 group off of it, it's still referred to as aniline. If we have other groups, then we have to deal with that using whether they're on the nitrogen as using the nitrogen N prefix, or if they're on other parts of the benzene ring, then how we would ordinarily deal with those names. So for instance, there we see at the far left aniline. For the second case where we have a bromo substituent off of the ring, that's 4-bromoaniline. Notice the aniline is more important than the bromo, the halide. We saw the halides are the lowest priority groups, so we know that we're going to go with the aniline is the parent name, and then the bromo is the substituent, or if we're doing common names, that's para, the para position, so para-bromoaniline. Next we have an aniline that has, instead of being a primary amine, it's a secondary amine, so that's N-methylaniline. And then finally we have now a tertiary amine, N-N-dimethylanilin. So hopefully you've caught on to the scheme and you're doing well with your amines, whether they're involved with straight chain alkanes or alcohols or aromatics. Hopefully you've caught on to that scheme. Let's take a moment to assess how well you've caught on by doing a learning check. Here you're asked to give the common and IUPAC names for each of the following. So similar to our earlier IUPAC naming learning check, only this time we've got at least one aniline example down at the bottom. So go ahead, pause the video while you complete that work and start us back up when you're ready to check your work. Good luck. Okay, so for our first case, don't let it trick you the way we show it. Of course, the methyl group is to the left, but the ethyl group to the right is longer, so it's an ethanamine in the IUPAC nomenclature scheme, or an ethylmethylamine in the common nomenclature scheme. If we go with IUPAC again, we do have to account for that methyl group, so it's an N-methylethanamine. For B, now we've got a longer carbon group there to the right, and that's the butyl group. So we have in the common naming scheme, because it's alphabetical order, it's butyl ethyl methylamine, so not based on the length, although we do happen to go from longest to shortest. That's not because that has any special place in the common nomenclature, it's just that the alphabetical order happens to follow the decreasing length. So butyl ethylamine would be the common name. Butyl ethyl methylamine. Or if we look at our longest chain, it's a butanamine, and we're in position 1 there, so we're a 1-butanamine. We're also an N-ethyl N-methyl 1-butanamine. So there we have it in IUPAC format. Finally, the last one I sort of gave away, I mean, no other way to say it, but aniline, it's not substituted with anything else on either the nitrogen or any of the ring positions, so that's plain old aniline. Hopefully you had no trouble with that one. If you did have trouble with any of them, please do try some more practice naming problems, or certainly reach out to me for help if necessary. We did deal with this a little earlier as part of one of those early learning checks, but let's just be clear about classification of amines. Amines are classified as either primary, secondary, or tertiary, and it's all based on a number of carbon groups that the nitrogen is bound to. So in a primary amine, and we show that as like the one with the degree symbol as a shorthand notation, there's only one carbon group bonded directly to the nitrogen atom. In a secondary amine, and then you see that same sort of Arabic numeral 2 with the degree symbol, that has 2 carbons directly bonded to the nitrogen. And then finally a tertiary amine has 3 carbon atoms bonded directly to that nitrogen. Of course, in a typical amine, there's still a lone pair on the nitrogen, so we can't go beyond that, although quaternary ammonium salts would have an additional bond to a carbon group, and that's why we call them quaternary, but it also involves giving them a formal positive charge, which is why we call them quaternary ammonium salts. So there we see regular old ammonia rather, which is not an amine because it has no NC bonds. Then we see methylamine, which has a nitrogen carbon bond, but only one. The other two remain nitrogen-hydrogen bonds, just as in ammonia. The third structure there from the left, dimethylamine, has two NC bonds and one NH bond. That makes it a secondary amine. And then finally, trimethylamine has three NC bonds and therefore is a tertiary amine. We'll wrap up this chapter with something that I addressed in an earlier learning check as well, and that's how to do the skeletal formulas of amines. So as I mentioned back there, please realize that you will show any hydrogens bound to the nitrogen of the amine. So in the first case where we have a primary amine, we'll just show it typically as an NH2. When it's a secondary amine, we show it as an N single bond H, and a tertiary amine has no hydrogens left to bond to the nitrogen, so therefore we don't show any NH bonding because there aren't any. So there we have the three possibilities for skeletal structures: primary, secondary, and tertiary amines. So again, we do not show the hydrogens bound to the carbons that are points in that skeletal structure, but we do show when there's any hydrogens connected directly to the nitrogen of an amine. So hopefully that clears up any lingering doubts you might have had. Certainly reach out to me if there are still any things that you're not quite clear on, but otherwise we'll see each other in the next lecture of chapter 18.